guys are working on, or we're working on that state test, and I hope you guys will actually, I hope you'll actually communicate with me and tell me what you want to talk about. But over the next few days, guys, I'm going to try to get you some experience with these state tests. Obviously, a lot of these questions are pretty tough. They require you to remember everything you've ever learned in algebra, even sometimes in geometry, which is also a trickier thing. I can help you with the problems on this geometry, but a lot of the stuff you learned from the geometry master. I learned from Ms. Wakefield, who had some serious issues, and that probably, I basically think through geometry by thinking through trigonometry, which is not the easiest way to go. So I don't know tricks. I just redefine it, well, and calculus. I just redefine everything. So my path is sometimes really long. On my keys, I usually have a pretty good option because I ask Kilmer, hey, is there a shortcut for doing these problems if I don't see one? But if you want to have some really good geometry help, he's probably a better go-to. Take a picture of it and send it to him. He'd probably be excited to help you. If I can't give you a better answer. So what I want to do is this state test F. I asked you guys, did I say 1 through 25 or odds for you guys? Odds? Okay, I'm going to answer all the odds. And then tomorrow, we're going to go through the evens, which means that's your homework tonight. And I realize that it's a 2-hour state test. So when I give you odds, I'm kind of asking you to spend an hour. And I know that's a lot to do for 8 days straight. But if you can just do it from here, remember, not this Saturday, but next Saturday is our state tournament here in the morning. If you have a school conflict with that and need to get out a little earlier, talk to me. If it's a school conflict, I can work that out. I don't want it to be like, oh, well, I just want to get done early because I want to go to the park. It's not really practical to do that for us. But if we have to make an exception, we can probably do it. I think Helmers has a small group of people he's going to begin testing, but it's going to be like in a different room. We're going to be testing all of you guys down in the lunchroom, and we're just going to have you spread out on the tables throughout the whole room, just kind of mixed in. You might be sitting with a geometry person and algebra 2 person, but you'll be all mixed in with like different colored tests. You'll have a preference between yellow, pink, and blue.
Blue sounds nice and light.
Blue sounds nice and soothing. Okay, we'll go blue. I asked my other class in algebra 2, and they were like, nobody had any consensus. Blue. Soothing blue it is. Okay, so you will have the soothing blue test, and then I think algebra 2 is going to have white, and we'll just give geometry whatever the leftover colors. Pink or yellow. Anyway, we're going to do that a week from Saturday in the morning. You'll be out of here by 11, and then we'll just hope for the best in that regard. So let me read through the odds, but I'm going to give you a copy of this key tomorrow. I don't want to give it to you tonight because then you'll have the key and you probably be like, oh yeah, and you won't really think. And I really want you to try to think through these problems. So here are the answers to the odds. All right. So 1 is A, 3 is C, 5 is A, 7 is D, 9 is E, 11 is D, 13 is C, 15 is A, 17 is B, 19 is D, 21 is B, 23 is C, 25 is A, 27 is A, 29 is A, 31 is D, 33 is A, 35 is D, 37 is A, 39 is C, 41 is A, 43 is B, 45 is D, 45 is D, 47 is B, 49 is B. And if you're trying to figure out your score, not that the evens are going to give you the same score as the odds, but if you're just doing the math on it, you remember you get 5 points for being correct and 1 point for leaving it blank. So that means if you don't think like, oh, well, guessing doesn't hurt me, I don't get a -1. You kind of do, because you got 1 for leaving it blank. If you guess and miss it, you get a -1. So like anything, guys, don't guess on this. People think that guessing is going to help them, and occasionally it does. And what I mean by guessing, I mean, if you have literally no idea, none, it doesn't benefit you to guess. And please don't think that you can look at a set of questions of which you have absolutely no thought on and go, ooh, I bet it's this one. Because literally the designer of the test is going to design the test to make certain questions or certain answers look really nice to you. So they're trying to draw you in. Okay. In fact, honestly, a better way to go about it would be to go, ooh, that one looks like a really cool answer. I'm going to not do that one. But again, the guessing, it's just, there's no benefit in it. I would rather you just stick to what you know and count on those points that you can bring in just by leaving them blank if you don't have any idea. All right. That being said, if you know a couple answers don't work, like for instance, if you're like, wait a minute, sine has to be positive in the first quadrant, and these answers, 2 of them are negative. Well, if you know like something like that, and you can go, oh, well, now I'm down to 3. Well, if you can even eliminate 1, the odds are in your favor. But certainly if you can eliminate a couple of them for a logical math reason, then certainly guess. But I don't consider that really guessing. I consider that mathematics. I mean, you're literally using probability in your favor. But random guessing, it normally doesn't end well for some reason. That's why you see these people getting negative. I saw somebody get a -18. I think somebody got a -21 once. I don't even know how you do that unless you literally know the answers and intentionally avoid them. Like, you're completely defeating the laws of probability. But it's because they're really getting drawn in by the sexier answers. You know, they're like, ooh, I like this one. Sucker, 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 over and over again. So don't let that happen to you. I would rather you just know what you know and go for it. But if you do count your score up, like say you got 10 right, which would be pretty great, honestly. I mean, at this point, if you got 10 right, that's 50 points. Let's say you missed 5 and you got the other 10 right, so a total of 60. If you can do 60 and 60 twice, you might not be in our top 4, but you're going to be in the state's top 25% with a 120, at least in our division. So our goal, obviously, for this particular test, I'd have to look it up, but if you can get usually in the 130, 140 range, you're helping our team, which not everybody's going to do. But if you can get in the hundreds or above, so if you scored 50 on this or above, that's not a bad score. You're probably been a while since I've looked at this test, so I might even have done something that surprises me. But I want to show you what I did and hopefully get you in a good spot. Anybody? Oh, and have you gotten this little state review? Okay. So we did odds. That's what we're going over today. We're going to do evens tonight, but you can just follow this. And everybody already has their packet. You've already got all your tests. And this is just going to carry us through the night. And then when we come back on the 12th, we'll jump into derivatives. We'll have 2 tests in derivatives, 1 in finance. So you won't have many questions. Oh, good. Yeah, and I don't think I have the packet on school sheet. All right. So anybody, and especially if you missed something, if you missed something that you thought you were doing correctly, please ask me about those. Let me try to get you straight. I know not everybody in here made a 125 on this. You're bound to have some questions. Five? All right, number 5. Okay, wonderful. Geometry. Okay, so on number 5, let me read it. Okay, so according to Helmers, this is something I did not know, but he said there's a bisector theorem, okay? And he said let me see what they gave you. They gave you 4 root 2, 8 minus 4 root 2. Okay, so if that's true, I called that x, and they said that this was isosceles. At some point, they said that ZE was equal to ES, so it's clearly not drawn to scale, but because they said that, I have to say that that side and this side are the same, okay? So at this point, I have labeled that side, and these two individual parts of that side. But evidently, there's a bisector theorem that you guys learned in geometry. It says that this side over its part of that is equal to this side over its part of that. Does anybody remember that from geometry?
Yes.
I get 1 yes. I can give you a strong no from Miss Wakefield. God bless her, but I did not learn anything to that level. But that is a true statement, evidently. So at this point, I just cross multiplied, cleaned it all up as much as I could, and got to here. Cleaned a little bit more of it up by dividing through by an 8, made it look a little bit better to me. And at this point, I'm solving for x, and I see that each of these has an x, so I factored the x out, and I divided both sides by a root 2 minus 1, which of course I had to rationalize, do a little bit of junk, and then finally got to that. But if you didn't know the bisector theorem, then you were kind of out on that question. But if you didn't remember that, try to remember it. All right, because it's not a really overly difficult theorem if you, but they did make the graph not to scale to kind of mess with you. So if you weren't reading it, you didn't catch that part, but it did say that those two sides were equal, even though they didn't look equal. But that's pretty common to have things not to scale. What else you got? Anyone? You gotta have a question.
Number 7.
7? Come on, guys, don't be shy on me. If you miss something, talk to me. If you made a 125, tell me, and I'll be really happy. So number 7 said the graph of this function has 1 root less than 0. So that means it's got 1 negative root, and it must have 4 positive roots. It says on which of the following intervals does it lie? And so on that particular number 7, I just decided to look down. Hold on. Oh, okay. I kind of used a little calculus mentality. But does this make sense? If we know that this is a polynomial, do polynomials ever have holes or vertical asymptotes or anything like that? They don't, do they? So if they don't have holes or vertical asymptotes, then that means if a graph is cruising along like this, right, or whatever, right, and it has 1 vertical, if I know that it has a negative root, right, then wouldn't it make sense that if I check a value on one side and it's positive, and then I check a value on the other side and it's negative, doesn't it make sense that the graph would have to cross through the x-axis in between those? Does that make sense? And that was some of Newton's laws that he does with root approximations that we really don't get into much in calculus. We talk about it a little bit with tangent line approximation. He uses that kind of mentality. He goes, oh, if I plug in something and I'm negative, and I plug in something I'm positive, then it stands to reason that there's something in between where I get a 0. Okay, so that's kind of the approach I took. I started looking at these intervals, -5, -4. -4, -3. These aren't points, right? These are intervals. So what that means is if I know there's a negative root, say, on the interval between -5 and -4, let's just say over here, here's what? We'll say 1, 2, 3, 4. If that's -5 and -4, if there's a root on that interval, then I should be able to plug -5 into the function and -4 into the function, and one of them is going to give me a positive number, one of them is going to give me a negative number, which means the graph must cross in the middle. So I didn't show all my work for everything, but I showed it for this one check, okay? Now, if you're thinking, why didn't you just solve it? What do you think happens if you try to solve this thing? And you learned how to solve with synthetic division and possible rational roots. You probably don't get any answers that are nice and neat. You probably go through all the possible rational roots, of what you got, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and you don't see anything. So then you kind of get frustrated. So I just went through and checked all the intervals, and I noticed when I plugged in -2 into the function, I got that. When I plugged -1, I got that. And you can see if one's negative and one's positive, that means it must have crossed through there. So this is not something that we've learned. If anybody did this and thought through this, that's fantastic. But it's not something we've ever learned or thought about, because what we have done is we've always assumed that there were enough roots that I could go and find the real ones or the rational ones, and then maybe at the very end use the quadratic formula for the last two. But if you ever need to know if there is a root, that's what a lot of times what people will do. They'll start with like positive 20, negative 20. And if one's positive and one's negative, they go, okay, I know there's a root in there. So they start bringing the numbers in. And they just bring them in more and more and more until they can narrow down where it is. And then there's other strategies to really be more exact. Like you'll learn in calculus something called a tangent line approximation. And I can approximate the square root of 53 or something like that accurate to 4 decimal places, 5 decimal places, 6 decimal places, just using tangent lines and things like that. So anyway, that's what I did there. But I just kind of guess checked and revised and checked using the points that they give me. Unfortunately, I had to go all the way to D to get it, but I didn't show all that work. What else? Come on. You had to have missed something.
You're 17.
17. Now, I really hope you guys will just not come in here quiet, because we've got a few days of this. So really come in. If you don't know how to do something or you're curious about something, if you don't ask, somebody else is going to ask something else. All right, 17. It's a log problem. I like log problems in that 99% of the time, they don't ask me anything overly brutal. So I know that I've learned it, which is kind of a comfort, because on many of these things, like the problem we just did, you hadn't learned that. But I got some comfort in the fact that I do know logs. So let's take a look at this. This says, find the value of log base 2 of blah. Now, is there anything? Now, again, don't assume the position. Assume you know enough. So I'm looking at log base 2 of blah right there. Is there anything about that expression that jumps out at you? Any one thing? I know it's kind of hard to see right here, but I see a log base 2, then I see a 2, a 4, an 8, all the way through a 5, 12. Is there anything about that that jumps out at you? Powers of 2? So how do you multiply powers of 2? Because I'm assuming if they're powers of 2, I could rewrite them, right? Like right here, I have 512 to the 9th. Isn't 512 to the 9th the same thing as 2 to the 9th to the 9th? Right? And what's 2 to the 9th to the 9th? 2 to the 81st? Could I do that with all of these numbers? Right? And I could change them all to base 2. And if I can change them all to base 2, think about it. This would give me 2 to the 1st, and then 2 squared would be 2 to the 4th, and then 2 cubed would be 2 to the 9th. Are you following me? And then 2 to the 4th would be 2 to the 16th. 2 to the 5th would be 25th, right? And you can kind of see it. 25th. What am I? I'm just doing squares, right? 2 to the 49, 64.
There we go. I was
just ahead of the game, right? 81, finally. So there's my 1, 2, 3, 4, 5, 6, 7, 8, 2 to the 9th. I've got all my values there. How do I multiply like bases? I add their exponents, right? So really, this is the same thing as 2 to the that power, right? So all of that inside part simplified to this. But don't forget I have a log base 2 on there. Well, what does log base 2 of that give me? It just cancels. And I'm left with that sum. Now, I actually learned a sum of the squares formula, and we have it on our summer reading packet that you didn't get. And I quizzed you to death on a summer reading quiz that you never took because of COVID killed that. But we would have all learned this formula had you been in a normal situation last spring and this fall. But we didn't learn it. But fortunately, we can still add that together, right? Now, there's one other way to do this. It's maybe a slightly, I don't know if it's easier, but remember the rule that if you add two logs, you combine it together by creating one log and then multiplying? Well, couldn't you undo this log the same way? You could say, all right, if it's one log and I'm multiplying, I could rewrite it as a bunch of logs added. I'm going to tell you, I don't think this is the best way to go, but I could have done that individually. And if you look at all these, they're still base 2 situations, right? So this is still 2 squared squared, which is 2 to the 4th. This is still 2 cubed cubed, which is 2 to the 9th. But if you did it that way, again, you could simplify this to 1 plus 4 plus 9 plus, but at the end, you can still add them. So even though you don't have a nice formula for adding them that you've learned and memorized, we can still do that. That would take you an enormous amount of time to do, even though it might be a little more annoying without that formula. Track with me? And that's a problem that I think we can do. We really can. And if we learn from little things like this, these problems start feeling familiar to me. They're kind of not the same, but the same kind of ideas in there. And they're usually pretty fair questions, I think, in terms of an ugly math test. They're doable. At the stadium, a lot of times I can't even do a couple problems. I'm like, I don't even know what they're asking or what little obscure trick they have up their sleeve. But on these, I can almost always do every problem, even if it might take me some creativity and some time that, of course, you guys won't have. You only get 2 hours. What else?
29.
29. Okay, 29. All right, I'm going to give you a nice little rule here that I didn't know about until last year, actually. Believe it's on this question. Okay, it says, let phi of n represent the number of positive integers, that they're calling k, that are less than n, with the greatest common divisor being 1. Now, they worded that really weird, but we've talked about a phi number before. Do you remember that? Or maybe we didn't. Gosh, I don't remember what you guys have done. We went to the state tournament, so I'm almost positive we did. Do you remember modular arithmetic, mods? Does this ring any bell for you? Something like, 129 to the 128 power. Does that look even remotely familiar to you? You do remember something, a couple of y'all? Some of y'all were in a haze. Some of you no recollection. You do have a recollection? Okay. So on a mod number, basically there's this phi number, and the phi number is the way to reduce this. Basically, when you ever see a mod, what that means is they want to know what is the remainder that you get if I divide this number by 7. Well, clearly that is a massive number, right? I mean, what do we know it through stuff like 2 to the 12 and 3 to the 8. This is 129 to the 128. That is an enormous number. So this falls under the branch of math called number theory. Has no business being in this class, this test, but comprehensive as anything they want to ask you about. So the way to reduce these numbers and make them smaller, or you can always divide this number by 7 and put the remainder in its place. You can also subtract this number by 7 and put the remainder in its place. And put the result in its place. So I could change that to 122 because I divided by 7. It's still a true statement. I could divide 7 into that. Take the remainder, replace that with a 3. And it's still a true statement. And remember, the goal is to find the remainder. So what I want to do is shrink this down. as much as I possibly can. Well, there's a trick to shrinking down exponents. And it's one of Euler's many brilliant theorems he came up with. And for me to explain it would take arguably maybe an hour and a half. I've got the notes because somebody explained it to me. And this is not a number theory class, so I'm not going to. But the trick is I can divide this by a phi number, the phi of 7. Now, the phi number is what they're asking you about in this problem. And what they worded, they gave you the definition of it, except that they gave it in a very wordy way. But the phi number, all it means is look at the numbers smaller than 7. 1, 2, 3, 4, 5, and 6. Which of these have only a greatest common divisor, that's the GCD? Which of them have a greatest common divisor of 1 with 7? All of them. And if you still don't know what that means basically, which of these numbers don't share a common factor other than 1? Well, 7's prime, right? So of course, if I'm looking at the numbers smaller than 7, none of them have a common factor with it. So how many of those numbers are there? 6? That's the phi number. Now, that's really easy to do with prime numbers, right? What it's not easy to do with is big numbers. Like, what if I said phi of 100? Are you really going to write out 1 through 99 and start canceling everything that has a common factor with it? It's going to take you a while to count all those up. So there's a trick to this. And the trick is what I'm about to show you. And you didn't need the trick on this one. They asked you what was phi of 15. Okay? So all you really had to do is write down all the numbers that were between 1 and 14 and start canceling anything that has a what in it. What are the factors of 15? 3 and 5? Because remember, these are smaller than 15, so you don't have to worry about 15. And you're allowed to have 1 in common. So you just look at the 3 and the 5. So I canceled everything with a 3 in it and everything with a 5 in it. And then I counted up the rest, and I got 8 numbers. Now, that wouldn't be hard for 15. But I can't just say 14 because 15 is not prime. Right? But there's a trick. And the trick is, let me make sure about this. Hold on, I'm going to have to check it with another number. But I think it's the factors. Dang it, did I forget my trick? What is it? Gabe found this on the internet. Gabe Keough. I'm looking at my work. Let me see. It's something about the number of factors. What is it? Oh, maybe it's this. And no, that can't be right. I'm thinking you take the number, and then you take the 3 and the 5 and make them denominators, and then you do 1 less than the 3 and the 5. Oh, I do know what it is. Okay, you do the prime factors. I know what it is now. You do the prime factorization of 15, which is 3 times 5. Prime factorization. Then you take whatever the bases are. What I mean by that is sometimes you might end up with like a 3 squared and a 5 squared, right? Still take the 3 and the 5. Put those on the bottom, decrease them by 1 to make these fractions, multiply it together. Okay. So like here's one, phi of 100. This is a very commonly asked question. And you need it in some other circumstances. Phi of 100 I have memorized, it's 40. Phi of 1,000 is 400. Phi of 10,000 is 4,000. It's always the 4 right below it, like 140, 10, 4. But the way you would do this is that prime factorization is 2 squared, 5 squared, right? 4 times 25. So you take the 100 and you take the bases, the 2 and the 5, reduce them by 1, cancel, multiply it out. That's the rule. I should have actually written the rule down as opposed to just the application. But yeah, you do the prime factorization, you ignore the powers, take these two numbers, put them on the bottom, decrease them by 1, multiply them by the original number. And it's a really short, quick way to find the phi number, especially when the phi number is big. And by the way, that phi number, it's pretty universally recognized. It's not like I'm just saying, hey, I pick a Greek letter like I do for an angle. They use phi for that number on this greatest common divisor or whatever situation. So, or least common divisor situation. So that's what they meant on this problem. It's totally something that gets asked all the time. We do it a lot with mods, but if you guys are hazy on the mod stuff, that's not great, but it does show up mod stuff, and we could talk about that more this week and next, but especially if one pops up. Because they're pretty doable. The mod problems they give are probably the easiest mod problems I've seen at math tournaments ever. Like sometimes they take 20 steps. The one that just showed up on an Algebra 2 test, 1 step. Like literally one thing you had to do and you were done. Hey, what else? Got 2 minutes. Let's sneak one in. And guys, come on. Tomorrow when you take this test, or tonight when you do it great at anything you miss, ask me about. We're just spinning our wheels if I'm just standing here. Have some good questions ready to ask. And don't be afraid that, oh, I missed this one. People are going to shame me. They're not.
Not much. It was
39.
39. See if we can squeeze this one in. And again, I'm going to give you the key so you can look back at these on your own. Some of these are really tricky on this test. Oh, this is terrible. Okay, so we don't have time. Remind me tomorrow, we'll look at 39.